Okay, so today we're going to learn about quadratic inequalities. But before we do, we're going to have this warm-up, which will refresh our skills on quadratic functions. So I want you to consider the function f of x equals negative 2x squared minus 2x plus 4. And the first question says, the graph of a quadratic function is a parabola. Does this parabola, f of x, open up or down? And then I want you to tell me how you know. The second question asks to find all the zeros of f of x, or all the roots, or all the solutions. So those are the two warm-up questions. Okay, so let's go over the warm-up questions. The first question asks if the parabola opens up or down. Well, this parabola opens down. And the reason it opens down is because the leading coefficient is negative. So a parabola opens down when the leading coefficient is negative. And in the other case, it would open up if the leading coefficient is positive. So that's how you know if the parabola opens up or down. You look at the leading coefficient. If it's positive, then it opens up. If it's negative, it opens down. Okay, so the second question asks us to find all the zeros of f of x. So why don't we start out by just rewriting f of x. And when we're finding the zeros, what we do is we want to find the values of x that make the right side equal 0. So, how do we go about this? How do we go about solving or finding the zeros of a quadratic equation or a quadratic function? Well, you can factor, you can do a completing the square, and you can also use the quadratic formula. So let's just manipulate this guy a little bit to make it a little bit more manageable for us to deal with. So we see that there's a factor of 2 in each of -2, -2, and 4. So we're going to not only factor out 2, we're going to factor out -2 to make the leading coefficient equal to 1. That always makes it a little bit easier. So 0 equals -2 is factored out. We're left with x squared plus x minus 2. And if you look at that quadratic right here, you can see that it's easily factorable, and it factors like this. Okay, so now you have the quadratic you started with completely factored into 3 factors: 2, x minus 1, and x plus 2. Remember, when you're solving an equation, you're looking for the values of x that make the one side equal to the other side. So in this case, we're looking for the values of x that make the right-hand side equal to 0. When we have a product of 3 factors, if any one of the factors is equal to 0, the whole side is equal to 0, right? 0 multiplied by anything, 0 or non-zero, is still 0. So finding the solutions to our quadratic function is as easy as setting these variable quantities, x minus 1 and x plus 2, equal to 0, and solving for x. So that's the zero product property, if you'll recall. Ta-da! We got the zeros being x equals 1 and x equals -2. That means those are the x-intercepts of this function if we were to plot it, f. Okay, so that's a good warm-up. Let's move on to the lesson. Today we're going to learn how to solve quadratic inequalities. And what do I mean by solving quadratic inequalities? Well, you're going to have a quadratic function involved in an inequality, and just as in the last part we were looking for the values of x that made the one side 0, now we're looking for the values of x that make the inequality statement true. The first step to solving any quadratic inequality is to get one side equal to 0. So we're going to get the right side equal to 0 here by subtracting -2 from both sides. So we take -2 away from both sides, and we get an equivalent expression right there. The next step is to actually pretend this inequality sign is an equal sign, just temporarily. And what we're going to do is we're going to find the zeros of this quadratic equation. Okay, so we're going to pretend that's a equal sign for now, and we can factor out a 2 again in this left-hand side here. So we factor out the 2 because we like that leading coefficient on x squared to be 1. And this is what we're left with. Now, you can look at this quadratic here in the parentheses and realize pretty quickly that it's factorable. Remember, it's worth noting that if you look at any quadratic function and you don't know whether it's factorable or not, you can always use the quadratic formula. The quadratic formula solves every quadratic equation. The thing is, it takes a lot more effort to do, and there's a lot more room for error. Factoring is the easiest method of solving a quadratic, but it's the least common if you're talking about quadratics that would actually appear in real-life situations, or any quadratics. The very small subset of them are factorable in nice ways like we do it. So anyway, long story short, you can use the quadratic formula, but you can factor, and the factored form is here. Don't forget that guy. And now, to find the zeros, we set each of these guys equal to 0 and solve, and we get the zeros, or the x-intercepts, are x equals 3 and x equals -1. Okay. So now, what we're going to do, and remember, this guy right here is the same exact thing as this guy right here, which was an equivalent expression to this guy. So we're solving this yellow inequality up here. Keep that in mind. So, but let's look at this right here. That is this right here. So what I want to do is essentially graph that guy, which these two guys, like I said, are the same guy. You just factored it out. Okay, well, we know the x-intercepts are here, 3 and -1. So let's just go over here and let's plot a graph. And we'll say -1 is right here, and that 3 is right about here. It doesn't need to be exact, it only needs to be a sketch, and you'll see why. Now we're going to ask ourselves, which way does this parabola open, up or down? And if you learned anything from the warm-up, you should know that it opens up, because 2 is a positive number, and 2 is the leading coefficient. So it opens up, and we can sketch the parabola to look something along these lines. All it needs to do is be a sketch. Okay, so there we go. That's my sketch of the parabola. Now, after you've done that, you can finally answer the question you're being asked. You're solving this inequality. We want to know, when is that guy I underlined in pink greater than or equal to 0? Well, it's greater. Where is 0? 0 is right here, right? Well, that 0 refers to y equals 0. So that 0 is right there. So where is the curve above that? The curve is above that, here and here. And certainly these lines extend. That's why I drew the arrows. They would extend to positive infinity there, right? So what x values make this statement true? it's exactly these x values. All of them. There's an infinitude of x values that make that true, so we're going to have to define it in interval notation because it's a whole set of values. It's an infinite set of values there. And the last question I have to ask you is -1 and 3 included in this set of solutions? We can see that it looks like they're included, and they are in this case because when x is -1 or 3, it's equal to 0, right? It makes it equal to 0. We were pretending that was an equal sign. So they're included this time, but if you didn't have this, and it was just greater than, they wouldn't be included, and you would kind of do this open circle, and when you wrote it in interval notation, you'd write it a little bit differently. But turns out it does have the greater than or equal to sign on there. So our solutions are all the x's in the range of -infinity to -1, including -1, union with the set of real numbers from 3, including 3, to positive infinity. That's the solution to that quadratic inequality. Okay, so let's review what we did there. The first step was we had to make one side 0. So we add, subtract, whatever we need to do to make it 0, but legally. The second thing we did was we found the zeros for the non-zero side, or we found the solutions or the x-intercepts or the roots for the non-zero side. So after we found those x-intercepts, we plotted them on the graph, and then we determined the shape of the graph. We did that by looking at the leading coefficient. Then, since we know the intercepts and we know the general shape of the graph, we were able to do a quick sketch of the function and sketch the function on the non-zero side. So we sketched our parabolic curve on the graph, and we took a look at it, and then finally, step 5 was we were able to determine the solution graphically. All we did was we looked where the curve was above the y-axis, where the curve was above 0, or equal to 0, right? We had greater than or equal to this time, but you have to be careful when you look at that sign. But in this case, it was looking for all the values of x that made the curve equal to or greater than 0. Okay, so 5-step process for solving quadratic inequalities. Let's practice on one more. So, problem asks you to solve -x squared minus 2x plus 12 greater than 4. And as we said, the first step is getting the one side equal to 0. So I'm going to get the right-hand side equal to 0 by subtracting 4 on both sides. So that's what I do. Okay, so now what I want to do is I want to find the zeros, or the roots, or the solutions to this right-hand side. So we're going to pretend that's equal to 0 for a second, but we're not going to really do that. We're just going to think it in our minds. And we're going to go about it the same way. So let's factor out a negative, because I like that positive coefficient of 1 as my, leading coefficient next to x squared. So we're just factoring out a negative there. And again, we see this guy as factorable. Remember, quadratic formula can always be used if you don't see the factoring right away. Don't waste a lot of time looking for the factoring. So here we go. We're going to factor this as x plus 4, x minus 2. Now remember, we're kind of thinking of this as equals, and we're going to solve this equation at this point. And the way we do it is we're just going to set these factors with x in them to 0 and solve. So we do that, and we solve, and we get -4, and we solve, and we get 2. So these are our x-intercepts. Let's plot our graph. Okay, so remember, we're plotting this function right here. And we're going to see where it's above the y-axis, or above 0. So the first step in plotting, it's plotting the y-intercept. So we'll call -4 right here, and we'll call 2 right here. Remember, it doesn't really matter that much. It's just the sketch. Just do the best you can. You look at the function I underlined in pink, and you notice that the leading coefficient is -1. Since the leading coefficient is -1, it opens down, right? The parabola opens down because -1 is less than 0. So we're going to kind of have something like this. Alright, now the function's graphed, and our last step was to determine our solution graphically. So like I said, we wanted to know when that pink curve is greater than 0. When is it above the y-axis, or the y = 0 line there? And it's above it right here, right? So all these x's in here, in this range, make it greater than 0. Make the inequality true. Solve our inequality. Now, it's worth noting, is -4 and 2 in this solution? No, they are not, because -4 and 2, when you plug them in to this guy right here, you will get 0, and we want greater than 0, so they're not involved. Therefore, the solution is x in the range of -4, 2. Quadratic inequalities. First step, get 0 on one side. Second step, find the zeros or the roots or the solutions. Third step, plot these guys. Fourth step, plot this guy by looking at this guy. Fifth step, determine the solution graphically. That's how you solve quadratic inequalities.